we're going to start talking about equations of lines in two variables. And in order to do that, I need to give you a quick introduction to the rectangular coordinate system. When we talk about two-dimensional objects in space, one way of describing their location is using a rectangular coordinate system, which consists of a horizontal number line. That's going to be our x values or our x-axis. And then we'll have a vertical number line, which will be our y-axis or y values. These number lines intersect at what we call the origin or the point 0, 0. And we put the positive x's to the right, the positive y's go up. We can then describe any single point based on two different numbers, where it is on the x-axis and where it is on the y-axis. This is a lot like if you're given GPS coordinates, you're given two different numbers that describe your location on Earth. So right here in blue, this would be the point 2, 0, because it is at a value of x equal 2, and then it lines up with y equals 0. We write that as an ordered pair, so in parentheses. That's what I have in blue on the screen. And we always put the x number first, in this case 2, and then the y value next, 0. Here's another point. This point lies on the y-axis, so it has an x value of 0. So this point in blue has an x-coordinate of 0 and a y-coordinate of -3. So the ordered pair would be 0, -3. All right, and here's one more point. This last point that I drew has an x value of 3 and a y value or height of 2. So this would be the point 3, 2. Again, we put that x value first and the y value second. That's why these are called ordered pairs. The order that we write the numbers in is important. All right, so let's run through an example. If we want to plot the following points, 2, -1, 4, 0, and -2, -2. Let's start with 2, -1. So the x value is 2, and the y value is -1. So that means I would go over 2 on the x-axis, down 1 on the y-axis, and there's my point, 2, -1. The point 4, 0, that means the x value is 4, so I go over 4. And since the y value is 0, we don't go up or down. 4, 0 just sits on the x-axis. And finally, the point -2, -2, both x and y are -2. So I'm going to go to the left. There's x equal -2. And then I have to go down -2. And that would be the point -2, -2. Okay, so now let's start to talk about linear equations in two variables. So the equation 2x plus y equals 4 is a linear equation because it doesn't have any exponents or square roots, and it's got two different variables, an x and a y. So the first thing we're going to do is talk about solutions to these equations. I've got a list of 3 ordered pairs, and we're going to determine whether each ordered pair is a solution. So the point 2, 0, x equal 2, y equals 0. To figure out if an ordered pair is a solution, we're just going to take those numbers, plug them into our equation, and see if we get a true statement. So I replace the x with 2 and the y with 0. 2 times 2 plus 0 does equal 4. We do get a true statement, so that means yes, the point 2, 0 is a solution. What about the point 1, 1? X is 1, y is 1. We can run through the same process. If I plug those numbers into my equation, 2 times x, which is 1, so 2 times 1 plus y, which is also 1, does that equal 4? No, because 2 times 1 is 2, plus 1 is 3. That is not equal to 4, and so the point 1, 1 is not a solution of this equation. Finally, last one, x equal 3, y equal negative 2. I'm going to plug those numbers into my equation. 2 times 3 plus negative 2, that's 6 plus negative 2, and yes, that does equal 4. So 3, negative 2 is also a solution to this equation. And it turns out that our linear equations in two variables actually have an infinite number of solutions. There's an infinite number of ordered pairs that you can come up with that satisfy this equation. And so the next thing we're going to do is find solutions if we're given one of the variables. So the directions say complete the table so all points are solutions to the equation y equals 3x plus 4. So in this table of values, we are given either the x or the y, and we have to find the other variable. So let's start with x equals 0. To solve, we're just going to take the number given and plug it into our equation. So I'm going to take 0, plug it in for x, and I get y equals 3 times 0 plus 4. That's y equals 4. So that means when x is 0, the y value has to be 4. The point 0.04 is a solution to this equation. We can do the same thing for x equal 2. I'm going to plug 2 in for x, so now I've got y equals 3 times 2 plus 4. That's y is 6 plus 4, or y equals 10. So the point 210 is also a solution. All right, what if x is negative 1? Same idea, plug that in. Y is 3 times negative 1 plus 4. That's negative 3 plus 4, or 1. So when x is negative 1, y is positive 1. There's another solution. And then finally, we could be given the y value. If y is 7, we're going to take the 7 and we're going to plug that in for y. And so now we have just a tiny bit more work to do. We're left with 7, that was my y, equals 3x plus 4. And we're going to solve this for x. So to get the x by itself, we have to minus the 4. That gives me 3 equals 3x. Divide both sides by 3. 3 divided by 3 is 1. So x is 1. When x is 1, y is 7. And there's another solution. We could continue doing this for any number of points. So if you want to find solutions to a linear equation, you just need to know one variable, plug it in, and then you can solve for the other variable. All right, finally, I'd like us to go back to our rectangular coordinate system and just try to visualize what do these solutions look like if we were to graph them. So I'm going to graph all of these points and see what happens. So I've got the point x is 0, y is 4. So x is 0, go up 4. Now I have the point 210. So x is 2, and then go up 10. Negative 1, 1. X is negative 1, go up 1. And then finally 1, 7. So x is 1, and then I'll go up 7. And it turns out if you plot all of the solutions to a linear equation, they will always lie in a straight line. That's one reason why we call them linear equations. And in fact, if I connect the dots here, I do get a straight line. And every single point on this line will actually be a solution to this linear equation. We're going to pick up on this idea in the next video, so I'm going to stop here, but we will continue talking about these linear equations in future videos. Until then, please let me know if anything from this video is unclear.